Hello. We have Jude Baffabani here, a profound physics scholar. Hey, I want to ask you a question. If I submerge this regular Coke can in water, what do you think is going to happen?
I think it's gonna float.
It's going to float? Alright, well, what about Diet Coke?
I think that's gonna sink.
It's going to sink. Wow. So this we're back with the bones. So Bones, I want to ask you, if I put this in the water, what do you think is going to happen to the Diet Coke?
Well, I believe that you put both the Diet Coke and the regular Coke in the water, and they're both gonna float. You know why? That experiment we did, the oil and the water, what happens? They separate. Water and Coke are not the same thing, so I believe that they will separate and they will float. Boom, physics.
Alright, so we have one of our British literature teachers over here. We're gonna ask him a question. So, if I submerge this can of Coke in the water, do you think it's gonna float or do you think it's gonna sink?
It's gonna float.
It's gonna float. What about the Diet Coke?
Sure. It's gonna same thing. All of them.
Same thing?
Either all gonna float or none of them are gonna float.
Alright.
Let's go. Today we're gonna put these Coke cans into this container full of water, and we're gonna see what happens to them. First, we're gonna put in the regular Coke can. Pretty normal. Both of them are closed, as you can see.
Probably float.
Make sure there are no air bubbles underneath there. That one sinks.
Okay.
And now we got the diet
Same
one.
size, probably sinks too. Right? Whoa, are you sure it's not air bubbles?
No air bubbles underneath there.
Alright, so the best way to learn is to pay attention.
So here we have a visual diagram of what experiment just happened. Regular Coke, Diet Coke. Since they're the same volume, they both have the same buoyant force upwards on them, pushing up. However, like we said, the Coke is more dense, therefore has more weight. This weight force on the regular Coke is greater than the weight force on the Diet Coke. Because of this, the weight force for the regular Coke is greater than the buoyant force on the Coke. But for the Diet Coke, the buoyant force is greater than the weight force. Therefore, Diet Coke floats, regular Coke sinks.
And if you want to see how much 39 grams of sugar is equivalent to, this is what 39 grams of sugar looks like, just in case you want to know before you put a can of Coke in your body. Now we're going to see what two different types of Mountain Dew cans will do.
So now that you know that the Diet Coke was floating because it was less dense due to sugar, we're going to try it out on these Mountain Dew cans. This one has only 20 grams of sugar, while this white one has the 35 grams of sugar. Alright, let's try it out. Here's the 20 gram one. That floats. Alright, that was not part of it, but that one sinks.
Wow.
How about that?
So I have a theory that the soap water is going to make a difference. So let's see. This should float, like you've seen earlier.
I don't know what that does.
It's floating.